And good morning, fourth grade students of room 502. Welcome to Eureka Math. And Eureka is a Latin phrase that in English means, I have found it. And what have we found, ladies and gentlemen? We have found the best way to learn math, which, as you know, is more valuable than gold itself. So let's continue on with our lesson. Yesterday we talked about meters and centimeters and kilometers. Today we're moving from length in the metric world to mass or weight. Two different things. We're going to kind of use them together. So we're going to express metric mass measurements in terms of smaller unit, model and solve addition and subtraction problems involving metric mass. And mass is simply how much space something takes up. For example, our friend here, the counting crow, let's find out how much space you take up. Here we go. Maybe you'll see this, maybe you won't. But the counting crow, he takes up, well, counting crow is heavier than I thought he was. Sorry, counting crow, no offense. Are you 20 grams? Looks like he's going to be between 10 and 20 grams. Let's see where he goes. Okay, we're starting to get some movement here. So counting crow is about 16 grams. Okay, so remember, one paper clip was 1 gram, so counting crow weighs about 16 paper clips, you could say, or takes up the same amount of space as 16 paper clips. So first thing we're going to do is we're going to convert some units. Are we ready for that? Let's do, and you could write along on your scratch paper, 1 meter equals blank centimeters. What's our answer there? Well, we know 100 centimeters equals 1 meter. And let's take a look and do 2 meters. How many centimeters will 2 meters be? Well, if you think about it, you can see that 1 meter is 100, so 2 meters must be 200 centimeters. And we'll continue on with 3 meters equals blank centimeters. We'll think about that. 1 meter, 100 centimeters, 2 meters, 200 centimeters, 3 meters, 300 centimeters. And we'll move right along to, let's do 9 meters equals blank centimeters. Well, 3 meters equals 300 centimeters, so 9 meters must equal 900 centimeters. And then let's reverse it, and let's do 600 centimeters would equal how many meters? Think about that. So if 100 centimeters equals 1 meter, how much would 600 centimeters be? If you said 6, you are absolutely correct. We're going to shift some gears. This is length. Like I could measure this in centimeters. That'd be a nice thing to measure, this pen in centimeters. But now we're going to go to mass or weight, because if we used a metric scale, the mass and weight would be the same, but it gets very confusing. We'll just stick with mass, because that's what we have here. How much space something takes up. So mass is measured in grams, okay? And remember, and you can find another split space to work with. Remember, 1 gram weighed about the same as a paper clip. So we say 1,000 grams equals 1 kilogram. Just like 1,000 meters equaled 1 kilometer, this is 1,000 grams equals 1 gram. And we're going to go down the line here with 2,000 grams equals blank kilograms. You could fill in the blanks if you got the hang of it. 3,000 grams or 3,000 paper clips. We'll do 7,000. And then we'll do 5 kilograms equals blank grams. So if 1,000 gram is 1 kilogram or kilogram, 2,000 grams would be 2 kilograms. 3,000 grams would be 3 kilograms. 7,000 grams would be, oops, I missed the little G there. 7,000 grams would be, of course, 7 kilograms. So think about this. 5 kilograms would be how many grams? Well, 1,000 grams is 1 kilogram, so 5 kilograms would be 5,000 grams. All right, we're going to keep moving on down the line to the application problem. Okay, let's see, find out what we know. The distance from school to Zoe's house is 3 kilometers, 469 meters. Cammie's house is 4 kilometers, 300 meters farther away from Zoe's. So let's circle the 3 kilometers, 469 meters, and we'll circle the 4 kilometers, 301 meters. We need to find out how far is it from Cammie's house to school. We're going to solve using an algorithm or a simplifying strategy. So let's start out with what we have going on here. We have 3 kilograms. Well, you know what I like doing? Let's go with the tape diagram. And I know you can't see that, but that's okay because I'm going to tell you. So we're starting with our tape diagram. And what we're trying to find is how far is it from Cammie's house to school. And we know Zoe's house is, this is Zoe's, 3 kilometers, 469 meters. So go ahead and write that down, 3 kilometers, 469 meters. I'm going to do a little checkaroo of the screen here, make sure we're all in focus. Yeah, we're looking good. So 3 kilometers, 469 meters. And Cammie's house is 4 kilometers, 301 meters farther away from school than Zoe's. So we need to add these two amounts to figure out how far it is from Cammie's house to school. So you know that 3 kilometers is 3,000 meters, so we can just convert this to meters. 3,469 meters. This is one strategy, the standard algorithm. And we could convert this to 4,301 meters. It's just a matter of adding now. Pretty simple way to do this. So go ahead and add that. You can pause. Excuse me. So 9 plus 1 is 0. I'm going to drop my meters there. 6 plus 0 is 6. 4 plus 3, oops, I forgot the 1. Early in the morning. So let's start over. There's 7. 4 plus 3 is 7, and 4 plus 3 is 7. So Cammie's house is 7,700 meters from school. Now there's another way we could do this. We could go 3 plus 4 kilometers, right? 3 plus 4 equals 7 kilometers, right? And then we have the 469 plus 301 meters. 469 plus 301 equals what? Now here's kind of a cool way to do this in your head, kind of. We could take, break this apart, we could add 1 to it, so it's 470, and we subtract 1 over here, so it's 300. What would our answer be? It would be, look, 470 would be 770 meters. So our answer again would be 7 kilometers, 770 meters. Let's go ahead and write this up because we read, we draw, we write. Cammie's house is 7 kilometers, 770 meters from school. And it's better to put it that way, 7 kilometers, 770 meters than 7,700 meters. This is a lot easier to think about. Alrighty, let's continue on. We're going to need some scratch paper. Mr. Leggett's going to use a piece of scratch paper right here. And let's talk about let's stop right there because we're going to do something else, okay? So we're going to stop there, log on to Zern until I'm ready to work with you. All right, thank you.